Hi, all. We're going to talk a little bit today about the Pythagorean theorem. So the first thing I want to talk about is a proof for the Pythagorean theorem. In other words, why does the Pythagorean theorem work? So the first thing you need to remember about the Pythagorean theorem is that it's only happening for right triangles. So triangles with a right angle in them. So those are the only triangles that this theorem applies to. Do not try to apply the Pythagorean theorem to any other kinds of triangles. So we have to have a right angle here. And the other thing you have to remember is it is important how we name the different sides of our triangle to apply the Pythagorean theorem. So it doesn't matter which one is A and B. A and B are the two sides that are attached to the right angle. So notice here is our right angle, and A is one of the legs of the right angle, and B is the other leg of the right angle. And that's actually what we call them. We call them the legs. Now C is this other side that is opposite the right angle. And C has a special name. You probably have heard it before, but we call it the hypotenuse. I should have written this out before because I'm terrible at drawing with my finger on the mouse pad. So sorry about my writing, but that is the hypotenuse. And C is always going to be the hypotenuse. Okay. And so when we label our sides this way, the Pythagorean theorem looks like this: A squared plus B squared equals C squared. Now, we are going to look at a couple of GeoGebra manipulatives to show you that this is actually true in real life. So you may want to follow along. I gave you the links here. And you may want to follow along if you downloaded the notes. But if not, you can just follow along as I show them to you in the video. So we call this the proof without words because we need no words. You just watch what's going on. So A squared is going to be the area of this square, A squared. A is the side length here. And so the side length of a square is the same. So when we're finding the area of a square, we just do A times A, which is A squared. B squared is going to be the area of this multicolored square over here. Again, the side length is B. So when we form a square, the area of that square is going to be B times B, B squared. Okay, so we're talking about that, those two areas. And then down here, we have a side length of C. And the area of this square is going to be C times C, or C squared. So I'm just going to show you without words how A squared, the area of that square with the side A, plus B squared, the area of the square with side B, is equal to C squared, the area of the square with side C. So let's take a look as I drag this across, and you'll see these areas move down and fit magically like a little puzzle into C. So this is why the Pythagorean theorem works. Let me show you another example of this. Just another different kind of proof here. And this time we have here, it's showing you the area again, but this time it's in like liquid form, kind of filling up the area of these squares. And now I'm going to empty them into C, into the C squared. So you can see that the area of A squared plus the area of B squared is going to equal the area of C squared. So hopefully that helps you to understand the Pythagorean theorem a little bit more.